Okay, welcome back. This lesson will be quite similar to the last one, except that now we're not focusing on lines that are tangent to a curve, but rather those that are normal to a curve. And it is true that at any given point on a curve, the normal line is perpendicular to the tangent line. And now we have to remember what we know about perpendicular lines. In particular, we know that if we take their slopes and multiply them together, we will always get -1. So since dy by dx is the slope of the tangent line, the slope of the normal is given by its negative reciprocal. So -1 over the dy by dx value. Okay, so those are the concepts governing the lesson. So here's our first example. We are asked to determine the equation of the normal to y equals x squared minus 4x minus 5 at the point where x equals 1. So this is a parabola. Hopefully you recognize the equation of a parabola with a vertical axis of symmetry. The equation is given by y equals ax squared plus bx plus c. Okay, so this is definitely a parabola opening upward. So we begin as we did our previous lesson. If you're given a value for x1, make sure you find the corresponding y value. So when x1 is 1, y1 will be 1 squared minus 4 times 1 minus 5. And so this is going to give us -8. So now we have the point of interest, and it is 1, -8. So x1, y1. The next thing we need, of course, is the first derivative. So here's y. It's a polynomial. We take its derivative, 2x minus 4. And this is the expression for the slope of the tangent line at any point along the parabola. The point of interest is 1, -8. So when x1 is 1, the derivative is 2 times 1 minus 4, or -2. So what does this value represent? This is the slope of the tangent line to the parabola at this point. Y prime, or dy by dx, is the slope of the tangent line. In this question, we are looking for an equation for the normal. Therefore, we want to be using -1 over dy by dx. So -1 over dy by dx is equal to -1 over -2, or +1/2. So this is the slope of the tangent line, while this is the slope of the normal. If you want, you can remind yourself of that, right? Slope of the tangent line, while this number right here is the slope of the normal. Okay, after that, we use point slope form for the equation of a straight line. And remember, that was m equals y minus y1 over x minus x1. 1/2 equals y minus -8 over x minus 1. Okay, so again, m equals y minus y1 over x minus x1. And since we're looking for the equation of the normal, we're using the slope of the normal here. Now, before I cross multiply, I think I will make this y plus 8. So 1/2 is y plus 8 over x minus 1. So this will make things easier for us. And now you cross multiply. So you can go this way first and put that on the left, or this way first, putting that on the left. So I think I'll go this way. 2 times y plus 8 is 1 times x minus 1. Or 2y plus 16 is x minus 1. Everything on the left. 2y minus x plus 17 is equal to 0. So that's the equation of the normal. So let's have a look at the illustration here that I've included. So right here is the parabola given by y equals x squared minus 4x minus 5. The point of interest is 1, -8. So let's locate that on the graph. It's right there. Now in this first example, I've included both lines. This is the tangent line here that I've graphed. We didn't actually find its equation. However, we could simply by replacing 1/2 here on the left side with -2. Okay, so if we change this to -2 and proceed, we would have the equation of this line. I mean, I can do that for you right here. Okay, so this right here is the equation of the normal. If we wanted the equation of the tangent, the only difference is -2 would be on the left side here. So -2 is y plus 8 over x minus 1. Cross multiplication would look like this. Y plus 8 is just multiplied by 1. If it helps you, you can put a 1 under there to keep things straight. Y plus 8 is multiplied by 1. -2 multiplies by x minus 1. Y plus 8 is -2x plus 2. Or y plus 2x plus 6 is 0. So that's the equation of the tangent line. So that is the equation of this line right here. Its equation is y plus 2x plus 6 is equal to 0. And here is the normal line. You can see, of course, the whole key is that the two lines are perpendicular to each other. So the equation of the normal, this line right here, is 2y minus x plus 17 is 0. And that's the equation we were asked to determine in this question. Okay, I just kind of did this one to show you how similar it would be. The only difference is what you put on the left side for the slope. Okay, so that is our first example. Let's go look at a second one now. Okay. Oh, sorry. I can't be moving the papers. Oh, I'm seeing that there's a lot of sun coming in again. I don't know. Let me see if I can fix that at all. Not so much. Maybe I'll move. Sorry, guys. That's not great either. Give me another moment. Well, that's a little bit better. Sorry about that. Okay, let's try example 2. Determine the equation of the normal to 2x squared plus 8y squared is 40 at the point 2, 2. So let's begin. You can see that This is the equation of an ellipse. We did an example of an ellipse in our last lesson as well. So we are given here an x1 value as well as a y1 value. So in order to come up with the straight line equation, we need the derivative. So we take the derivative implicitly left to right. So the derivative of 2x squared is 4x. Put in your plus sign. The derivative of 8y squared is 16y times y prime, or 16y times dy by dx. Put in the equal sign, differentiate the number 40, and you get 0. Continue to isolate dy by dx. That means first this term will move to the other side, and it's going to be negative 4x. Now we divide by 16y. So negative 4x over 16y is an expression for dy by dx. We can reduce that though to get negative x over 4y. So this expression gives us the slope of the tangent line at any point along the ellipse. Okay, we're particularly interested in this point, 2, 2. So at the point 2, 2, dy by dx is negative 2 over 4 times 2. Okay, so of course we're substituting 2 for both x and y, and that's negative 2 over 8, which reduces to negative 1/4. So negative 1/4 is the slope of the tangent line. So we can put that in here as a little reminder. That's the slope of the tangent line to the ellipse at the point. Okay? Now, negative 1 over dy by dx will give us the slope of the normal. Negative 1 over negative 1/4. So negative 1 divided by negative 1/4 is the same, of course, as negative 1 multiplied by negative 4. So this is equal to 4. So 4 is the slope of the normal. Negative 1/4, of course, multiplied by 4 would give you negative 1. Okay, which is the property that holds true when lines are perpendicular. The product of their slopes must be negative 1. Okay, now we have everything we need. We've got an x1, y1, and the slope of the normal. So we substitute into point slope form. So 4 is equal to y minus 2 over x minus 2. So the slope, m, is equal to y minus y1 over x minus x1. Again, it's as though there's a 1 under here. Cross multiply in any direction you like. First, I'll go this way, so y minus 2 is equal to 4 times x minus 2. Y minus 2 is 4x minus 8. Or y minus 4x plus 6 is 0. Okay, because it's y minus 4x minus 2 plus 8. And that simplifies to give us this equation. Remember, this is the same as the equation with negative y, positive 4x, and negative 6 equal to 0. This same straight line can be described y equals 4x minus 6 if you like the form y equals mx plus b. Okay, and now for the illustration. Here is the ellipse. The point 2, 2 would be right here. This time I did not include the tangent line in the graph. If I did, right, it would look like that. The line that would be tangent to the ellipse would look like that. It would touch the ellipse at only that point. And notice it would be perpendicular to this line drawn, which is the normal. So the normal would be perpendicular to the tangent line at that point. So the equation of this line is y minus 4x plus 6 is 0. That's the equation you determined, or we determined in the problem. Okay, and again, at x equals 2, there is another point down here. The point would be 2, negative 2, and its slope right here would have the same magnitude but opposite sign. So the normal drawn at the point 2, negative 2 would have a slope of negative 4. Okay, but we weren't asked to determine that, but just a reminder of something we talked about in the last lesson also. All right, we're gonna do one more for this lesson. So just let me grab one more page here. Okay, I'm gonna move it down a little, still trying to avoid that sun. I mean, sun is nice in general, but maybe not so much for my video. Okay, so here we go. Determine the equation of the normal to y equals 4 over 5x minus 1 all squared at x equals 1. Okay, so here we go. This is one of those hyperbolic functions. You can tell by looking at this that the value y equals 0 could never be obtained. You would have to divide 4 by something infinite. So that sets up a horizontal asymptote at y equals 0. So the x-axis, in other words, is a horizontal asymptote. It means the graph will approach that line but never touch it. It kind of looks like these pieces of graph are touching the line, but that's just a shortcoming of the graphing software. In fact, the curve does not touch that line. And what is the vertical asymptote? It's the x value that would make this denominator equal 0. So it would be, I guess, x is equal to 1 over 5, or x is 0.2. That would be the value making the denominator go to 0. So we would have a vertical asymptote here. So this is 0.5, and we're talking about 0.2. So that would be sort of 0.2, something like that, I guess. Let me just try not to butcher this too badly for us. I think that looks pretty straight, maybe. This would be okay, so this is again y equals 0. This line I've put in, this vertical line is x is 0.2. So those are the lines that the graph approaches, however, never touches. Okay, in any case, let's go on and do the work that we need to come up with the equation. So we need a y value to accompany this x value because we need an ordered pair. So we know how that's done. When x1 is 1, y1 will be, this is a 4 in the numerator, So it's 4 over 5 times 1 minus 1 all squared. So what do we get here? We're going to get 4 over, so this is 4 squared. So 4 over 16 or 1 over 4. So that's our y1 value. So now we have the ordered pair given by 1 comma 1/4. As you know, we need the derivative, so we take the derivative of this function. We could use the quotient rule, but that would be way too much work for this kind of problem. If this is just a constant, we're better off rewriting this with a negative exponent. So the exponent will be -2, and now we use the chain rule. So the -2 comes forward, multiplies by the 4. The new exponent will be -3. And we remember to multiply that by the derivative of the inside of the bracket. The derivative of 5x minus 1 is 5. So this is -40 times 5x minus 1 to the -3, or -40 over the cube of 5x minus 1. Okay, now we're going to be substituting x equals 1 because we need a numeric value of slope, not an expression. The expression will give the slope of the tangent line at any point along the hyperbola. We want this specific value. So at the point 1 1/4, this derivative is -40 over 5 times 1 minus 1 all cubed. So it's -40 over 4 cubed, which is the same as -40 over 64, but this can be reduced. Both of these are divisible by 8, so you get -5/8. What does this represent? This represents the slope of the tangent line to the hyperbola at the point 1 1/4. Okay, since we want the equation of the normal, we use -1 over this value. -1 over dy by dx is equal to -1 over -5/8. So -1 divided by -5/8 is the same as -1 multiplied by -8/5. So of course we get +8 over 5. So this is the slope of the normal. Okay? The product of these two numbers is -1. All right, now we go to point slope form. So we write the slope on the left side and we set that equal to y minus y1 over x minus x1, like this. We cross multiply. So 8 is multiplied by x minus 1. Equal sign in the middle. 5 is multiplied by y minus 1/4. 8x minus 8 is 5y minus 5/4. Everything on one side will give us 8x minus 5y. Now for the constant, of course, it's -8 plus 5/4. Okay, Okay, so this is the same as negative 32 quarters plus 5 quarters, and therefore it's negative 27 quarters. Okay, and I'm all right if you want to leave your equation like that. And if you prefer, you could realize that this is the same as 6 1/4. So you could have the decimal here, 6.25. Okay, so after the negative sign, 6.25. Or if you don't like any of those options, you can clear out this fraction by multiplying all terms by 4, and that would look like this: 32x minus 20y minus 27 is 0. Okay, and I think that's the kind of thing the textbook will do, so be aware of that. They'll clear out any fraction. Okay, so let's remind ourselves what we did. We were given an x value. We had to find the corresponding y value. Y prime is found. It is the slope of the tangent line. We use its negative reciprocal so that we get the slope of the normal. Substitute into point slope form and simplify. So here's the hyperbolic function graphed. The point, remember, is 1 1/4. That's right here on the graph, okay? 1 1/4 is right here on the graph. This would be a height of 0.5, all right? So that's 1 1/4. And this is the straight line equation we determined. 32x minus 20y minus 27 is 0. Okay, the tangent line is not included in the graph, but it would be like this, right? It would be just like that. It's the line that would touch the graph at only that point. And notice it would also be perpendicular to the normal line drawn. Okay? All right, thanks a lot for working hard through this lesson here. Please try the 3 problems I suggested. They are listed in Blackboard. Have a nice day.